Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 16, 2025, about 3 days ago. This paper introduces a new model that can take a single, normal video of a moving scene and generate new, photorealistic video clips from different camera angles. The paper is titled Reconstruct, Inpaint, Finetune, Dynamic Novel View Synthesis from Monocular Videos, and as we'll see, its method of combining pre-training and test time adjustments is really clever. The authors essentially turn the problem into a smart inpainting task. So this first figure gives a great visual of that three-stage process. On the far left, you see the input, just a few frames from a normal video. The first step, labeled Reconstruct, builds a partial 3D map of the scene from a new angle, which is why you see those black, unobserved areas. Next, in the Inpaint step, the model intelligently fills in those missing gaps. And finally, the Finetune step polishes the result, adding realistic lighting and texture. You can see how it creates a really convincing new viewpoint. Building on that process, this figure gives a more technical overview of the model, which they call CogNVS. The left side shows the training phase. It's what's known as a self-supervised approach, which is a clever way to train without needing human-labeled data. The system takes a video, reconstructs its 3D geometry and camera odometry, that's essentially the camera's precise path and orientation, then creates its own training examples by masking out parts of that video. The model then learns to fill those gaps, preparing it for any scene. Alright, so moving to the results. This table compares CogNVS against other leading methods on two big synthetic datasets, Kubrick 4D and Parallel Domain 4D. The numbers tell a pretty clear story. Across metrics like PSNR and SSIM, which measure image quality and structural similarity, higher scores are better, and CogNVS is on top. It also gets the best scores for LPIPS, a metric that reflects how a human would perceive the image quality, where lower is better. This really shows the strength of that combined pre-training and fine-tuning approach. And those strong numbers are backed up by what we see visually in this next figure. Here, we get a side-by-side comparison on those same synthetic datasets, plus a real-world one called DieCheck. You can see the outputs from other models like GCD and Trojcrafter, and they often look blurry, incomplete, or just strange. In contrast, the CogNVS results are consistently sharper and more complete. They look much closer to the ground truth, which is the actual, real video frame from that new angle. This really drives home how well the inpainting and fine-tuning work together. So to really dig into why this method is so effective, the authors did what's called an ablation study, which is basically taking the model apart to see how much each component contributes. This table shows the results. The bottom row with both pre-training and test time fine-tuning is the full model, and it gets the best scores across the board. We also see metrics like FID and KID here, which measure realism. And for those, lower is better. When you remove either step, the performance drops significantly. It really proves both parts are critical. And this figure really gives us the visual proof to back up those numbers from the ablation study. On the far left, you have the input render with its missing pieces. In the next column, without pre-training, the model just can't fill in those big gaps. You can see it leaves a black patch. Then, without the test time fine-tuning, the image looks a bit off. The lighting is wrong, and the geometry isn't quite right. But the final column, with both steps combined, looks clean, complete, and geometrically consistent. It's a great demonstration. So, putting it all together, what this research really shows is the power of a hybrid approach. By combining large-scale pre-training on diverse videos with specific test-time fine-tuning, CogNVS can generate new views that are both photorealistic and geometrically solid from just a single monocular video. That's a video from one camera. It's a clever way to get the best of both worlds, avoiding the trade-offs that have limited older methods. That's all for this edition of the AI Research Roundup. Thanks for tuning in, and I'll see you next time.